So in this part of the discussion, we're going to talk about solution stoichiometry. So this is going to be dealing with stoichiometry like we've done before, except now we're going to be working with solutions. So the first step in any stoichiometry calculation is to always convert your given to moles. Whether it's grams, whether it's molecules, you always want to convert the given to moles. Well, now with the use of molarity, we have another way to convert information to moles. So if you're given a molarity and a volume, you can use the molarity equation, so molarity equals moles over liters, to take your molarity and your volume and go to moles. So using molarity and volume, make sure they're in the right units, we now have another way to convert our given to moles. So this example is in your notes. So it says given the following equation, and it gives you the equation, what mass of cadmium sulfide is produced from 158 milliliters of a 0.122 molar Na2S solution with excess cadmium-2 nitrate. So notice this problem is asking for mass of cadmium sulfide, so it's asking for mass of one substance, and they give you volume and molarity of a different substance. So you can use your molarity and your volume to go to moles of Na2S and then just stoich it out.
Okay, so in this example, it says we have this balanced equation. We have cadmium-2 nitrate, sodium sulfide, produces cadmium sulfide and sodium nitrate. So this question says what mass of cadmium sulfide, so mass is grams, so my answer should be in grams. So what mass of cadmium sulfide is produced from 158 milliliters of a 0.122 molar sodium sulfide solution with excess cadmium nitrate present. So first, the importance of this excess cadmium-2 nitrate is that we don't have to worry about it. It's not a limiting reactant problem. So what that means is I'm going to just use this given information to solve for grams. So this is a solution stoichiometry problem. So we have a balanced equation. We already have our equation, it's balanced. Now the first step in any stoichiometry problem is to go to moles. So what we're going to do is we're going to use our volume and our molarity to go to moles first. So molarity is moles of solute over liters of solution. So I have molarity here. So I'm going to take 0.122 molar. I'm trying to solve for moles. Now remember, it's liters of solution. Whenever you're given milliliters, convert it to liters. So divide this by 1,000, you move your decimal place over 3 times, it's 0.158 liters. So you're going to take your concentration, 0.122 times 0.158, that's going to give us our moles. So X is 0.019276 moles, and make sure you label your substance, that's Na2S. That's my moles of my given information. So always convert your given to moles. Remember, that's always the first step. Now, it's important to also label it because now that we're dealing with stoichiometry, we need to know what substance we're dealing with. So I'm starting, based on this information, with 0.019276 moles of sodium sulfide. Now, I don't want sodium sulfide, I want cadmium sulfide. So now we look at our balanced equation, and I want to go from moles of Na2S to moles of CDS. Remember, when you're converting between substances, the only thing you can use is moles, and that's because it comes from your balanced equation. So this is a 1-to-1 ratio. For every 1 mole of sodium sulfide, you make 1 mole of cadmium sulfide. That cancels my moles. Now, it doesn't want moles though, it wants grams. So I'm going to go from moles of CDS to grams of CDS. So remember, for every 1 mole of something, you have a certain number of grams. So that's going to be based on your molar mass. So if we look at our periodic table, cadmium is 112.41 grams, plus sulfur, which is 32.07 grams. I get 144.48 grams of cadmium sulfide for every 1 mole. So now I can just multiply this, 0.019276 times 144.48. I'm going to put my answer right down here. I get 2.78 grams, label everything, of cadmium sulfide. 2.78 grams of cadmium sulfide. So notice The only difference here between what we've done before and what we're doing now is that you have to use your molarity and your volume to find moles of your given. Then you go through, use the mole ratio, and go out to whatever unit you're trying to find.